Hey, I'm Brian Teller. I work in DevOps and SRE, and I run Teller's Tech. Ship It Weekly is where I filter the noise and pull out what actually matters when you're the one running infrastructure and owning reliability. If something's hype, I'll call it hype. If it changes how you operate, I'll break it down in plain English. Most weeks, this is a quick news recap. In between those, I drop interview episodes with folks across the DevOps world. Happy holidays, Merry Christmas, all that good stuff. It's the day after Christmas, so if you're listening while hiding from your family, checking one thing real quick, I respect it. Quick piece of housekeeping, the new site is live at shipitweekly.fm. That's where I'm putting links and show notes. Also, I'm looking for interview guests. If you're building real infra or platform stuff and you want to come on for a chill conversation episode, hit the email on shipitweekly.fm. If you've got war stories, even better. And one quick ask before we start. If the show has been useful, hit follow or subscribe wherever you are listening. And if you've got 10 seconds, a rating or review really helps way more than it should. All right, 3 main stories for today. First, Cloudflare wrote up how they built an internal maintenance scheduler on Workers. This is real platform engineering. Memory limits, data modeling, query optimization, caching, Parquet for historical analysis. Second, AWS databases are now available directly in Vercel Marketplace. It's a quiet shift, but it's a big one. Devs can click button real AWS databases from inside Vercel, but you still have to own governance, billing, and the blast radius. Third, there's an open source project from AWS called Team, Temporary Elevated Access Management, and it's built around IAM Identity Center. It's approval-based, time-bound access. This is one of those everybody wants it, few implement it cleanly problems. Then we'll do a lightning round, and we'll close with Mark Brooker's What Now handling errors in large systems. Let's get into it. Cloudflare has a really good post on how they built an internal maintenance brain on Workers. The core problem is kind of obvious once you hear it. When you run infra at their scale, you cannot rely on humans to remember every dependency and every weird routing rule and every if these two things go down at the same time, a customer's special setup gets wrecked scenario. So they built a centralized scheduler that treats maintenance like a set of constraints. Like, we must always have at least one of these routers active, or this customer pins traffic through these data centers, so don't take all of them out at once. The fun part is how they got it working within Workers' limits. Their first naive approach was basically load everything into one worker. All the relationships, all the product config, all the metrics, then compute constraints. And even in proof of concept, they hit out of memory errors. So they took a step back and said, okay, Workers have limits. We can't treat this like a giant in-memory analytics job. We need to only load the data that matters for the specific maintenance request. If you get a maintenance request for your router in Frankfurt, you probably do not need to load Australia. You need the dependency neighborhood around that router. That pushed them into graph modeling. They describe constraints as objects and associations, basically vertices and edges. Routers are objects, pools are objects, and the dependencies are associations. And then they built a typed association interface so the constraint logic stays simple, but the backing implementation can get smarter over time. Then they flipped their data fetching style. Instead of pulling down huge responses and filtering locally, they started doing targeted requests through the graph interface. They claim response sizes dropped by 100 times in one spot. That's huge. Also, it's the exact kind of win you get when you stop shipping your entire dataset into your app layer just to throw most of it away. Of course, that created the next problem. Sub-request limits. They traded a few massive requests for a ton of tiny requests. And then they started breaching sub-request limits. So they built a fetch pipeline with request deduping, a small LRU cache, edge caching via caches.default, and sane retry and back off. After tuning, they were seeing about a 99% cache hit rate on those fetches. That's wild. And it's also how you make something like this survive at scale without tuning your internal APIs into a crater. Then there's a super relatable metrics story. They use Thanos for Prometheus queries, and they call out what a lot of teams do by accident: ask for everything, get megabytes back, parse JSON into single threaded runtime, then filter most of it out. That's basically self inflicted pain. Instead, they use the graph to find the specific relationships first, then issue much more targeted Thanos queries. They say average response size went from multiple megabytes to about 1 kilobyte in one case. So the theme of this story is stop dragging huge blobs of data into your application just so you can toss 99% of it. And then they bring it home with historical analysis. Real time is one thing. Historical is a different beast because now you're scanning months of data to see if your logic is actually safe and accurate. They talk about how Prometheus TSDB blocks are not really designed for object storage access patterns, and how that turns into a lot of random reads. So they adopt a Parquet conversation layer for historical data, columnar format, better stats, and you can fetch what you need without slamming object storage with random I/O. Takeaways you can steal even if you're not Cloudflare. If you're building platform brains like schedulers, deploy orchestrators, policy evaluators, you will hit limits. Memory, CPU, API quotas, request fanout. You win by changing the shape of the problem, not brute forcing it. Graph interfaces are a cheat code for dependency-heavy domains, and targeted queries plus caching plus backoff is still undefeated. Alright, let's move from Cloudflare did adult engineering to developers can click button databases. AWS announced that AWS databases are now available on the Vercel Marketplace. The headline is simple. From Vercel, you can provision and connect to Aurora Postgres, Aurora DSQL, and DynamoDB in seconds. And here's the part platform folks should not ignore. The onboarding path is basically create a new AWS account from Vercel, with some starter credits. So the dev experience is you're already in Vercel. You click a thing, and now you have a database, and the app is wired up. That is great for velocity. It is also the kind of thing that bypasses governance if you don't get in front of it. Even the AWS side is legit. You still have to deal with who owns that AWS account long term. Is it inside your AWS organization, or is it an orphan account that exists because Vercel made it easy? How do SCPs apply? How do guardrails apply? How do you do tagging and cost allocation so finance doesn't show up later asking why there are mystery accounts? What does networking look like? Are public endpoints acceptable? Do you need private connectivity? Do you have a VPC strategy that fits Vercel first teams? What's your audit baseline? CloudTrail, config, detective controls, all the boring stuff. Also, region selection matters for data residency and latency. It's not just pick whatever. Vercel also hinted this is evolving. They're talking about coming soon support for provisioning into an existing AWS account, not just a new one. If that lands cleanly, that's the version I'd actually want as a platform team, because now you can meet developers where they are without losing governance. So the takeaway, if your dev platform can create AWS resources, your governance has to meet it there. The database is easy. The ownership model is the hard part. All right, story 3 is about access, which matters even more once you have more accounts and more surfaces. TEAM stands for Temporary Elevated Access Management. It's an open source solution built around AWS IAM Identity Center. The pitch is basically approval-based, time-bound, elevated access to AWS accounts. Users request elevated access for a specific period of time, with a reason. Approvers approve or deny it. If approved, access is granted. When time expires, it is automatically removed. That automatic removal is the whole point. Because most orgs fail here. Someone gets admin just for this incident, and then it stays for months. Privilege creep becomes the default. Team also leans into auditing and visibility. Who requested what, who approved it, when it expired, plus session logging. How I'd frame it. This is not your break glass story. Break glass is the world is on fire and we need access right now. It should be rare, noisy, and heavily monitored. Team is the daily, I need admin for 45 minutes to do this legit change workflow. If you want this to actually work culturally, approvals need to be fast enough that people don't route around it. And the default permission sets need to be sane, so elevation is actually meaningful, not just ceremony. If you are already on IAM Identity Center and you've been hand-waving we should do JIT access, Team is at least worth a look. Even if you don't adopt it, it's a good reference for what time-bound elevation can look like without building everything from scratch. All right, time for the lightning round. GitHub Actions improve performance on the Workflows page. Small change, but if you live in Actions, you'll feel it. Big workflows render better now, lazy loading, and you can filter jobs by status so you can just see failures or in-progress stuff. During an incident, this is a real quality of life upgrade. Next, the weird one. Lambda managed instances. This is basically run Lambda functions on EC2, but AWS manages the lifecycle of those instances for you. It's meant for steady-state workloads and specialized compute needs. It also changes concurrency and execution assumptions a bit. So you actually need to care about thread safety and shared state in ways you might not with regular Lambda. Interesting, slightly cursed, but I get why it exists. Atmos quick hit. There's a Cloud Posse Atmos issue where vendoring a component with an invalid URL triggers a weird GitHub username prompt. I'm mentioning it less because of the bug and more because Atmos is clearly turning into a bigger workflow ecosystem now. CLI, dev containers, IDE integrations, the whole thing. And last, K8sdiagram.fun. It's a free Kubernetes diagram builder that can also generate YAML for common resources. I would not blindly apply auto-generated YAML to prod, but for teaching, prototyping, or explaining architecture to humans, it's actually super handy. All right, let's close with the human story, because this ties into everything we just talked about. Mark Brooker wrote a post called What Now? Handling errors in large systems. It's basically an interactive error handling game. You decide whether a system should crash or keep going when something goes wrong. And then he explains his take. The key idea is simple, and it's something we forget all the time. Error handling isn't a local decision. It's a global property of the system. We love to argue about one line of code. Should this crash? Should this retry? Should this be best effort? Mark's point is that decision only makes sense if you understand the architecture around it. He asks questions like, are failures correlated? If the same bad input can hit every node, crashing can amplify the blast radius. Can a higher layer handle the error? Some architectures are designed to tolerate a few crashes. None are designed to tolerate a ton of crashes continuously. Is it actually safe to keep crashing? Is it actually safe to keep running? Sometimes continuing means silent corruption, which is worse than a crash. Then he ties it to blast radius reduction. Cell-based architectures, independent regions, isolating failures so you don't have a single mistake become a global outage. That connects to today's stories perfectly. Cloudflare's scheduler exists because humans will guess wrong sometimes, and the systems need to prevent correlated failure. The Vercel Marketplace DB story is a new surface area. The failure modes aren't just technical, they're governance and ownership failures. And Team is literally about reducing the risk of one person with standing admin turning a mistake into a disaster. So yeah, if you want a good mindset going into next year, stop treating air handling like a code style preference. Treat it like architecture. All right, that's it for this episode of Ship It Weekly. We covered Cloudflare's maintenance scheduler on workers and the platform limits force better design lessons, AWS databases inside the Vercel Marketplace, and what that means for governance and blast radius, and Team as a practical path to time-bound elevated access with IAM Identity Center. If you got something out of this, hit follow or subscribe wherever you are listening. And if you can, leave a quick rating or review. It's annoying how much that helps the show. Links and show notes are on shipitweekly.fm. And one last reminder, I'm looking for interview guests. If you want to come on and talk through real DevOps or platform work you're doing, hit the email on the site. I'm Brian. Thanks for listening. Happy holidays, and I'll see you next week, which is technically next year.